Welcome to you in this first lecture of composition of forces. When we talk about composition of forces, then it means that the forces will be one than more. Means it will be a quantity of forces, maybe finite or infinite number of forces. So let we find the resultant of two forces. Means that we are composing over here two forces. So the forces here we are taking F1 and F2. These are the two forces, and we want to find the resultant of their forces. As you know that forces are always vector quantities, so therefore we represent these forces just like we write the arrow on the top of the forces F1 and F2, and let these forces are acting on a point, and suppose that that point is O where these forces are acting, and we let that alpha be an angle between these two forces F1 and F2. Okay, so alpha is the angle between these two forces. Okay, yes, so our target is to find the resultant between these two forces. F1, the first force is F1 and the second force is F2. So since we want to find the resultant, so we let over here that R be the resultant. Let R be their resultant of these two forces, F1 force and F2 force. Okay, so this resultant makes an angle theta with the force F1. Okay, now we draw the figures by these statements that we have right. Okay, yes, we will take the force F1 and the second force is F2. So on the over here we will write F1 force, and over here we will write F2 forces by the parallelogram law, also called it parallelogram law. So this F2 force can also be represented on the other side. So let this is the line which is the resultant line. Okay, so this is the resultant of the two forces F1 and F2. F2 force can be represented by the parallelogram law. So alpha is the angle between F1 and F2, and theta is the angle between the resultant and the force F1. It's okay. So by the head and tail rule method, we know that resultant is equal to the sum of the forces. Means the resultant is equal to the force F1 and the second force which is F2. F1 plus F2. Okay, so now we take the dot product of R is equal to F1 plus F2 with itself. Okay, taking dot product with itself. When we take the dot product with itself, then it means that we want to take the dot product just like as, yes, or dot or, and this is equal to F1 plus F2 with itself, means F1 plus F2. So when we take the dot product of two vectors, then it will convert into square. So it will be R square, which is equal to F1 vector dot F2 vector, yes, F1 dot F2 plus F1 dot F2, and the second is F2 dot F1, and then F2 dot F2. Since F1 and the same vectors, when we take the dot product of the same vectors, then it will convert into square. So F1 dot F1 will convert into F1 square, and F1 dot F2 plus F2 dot F1 will be equal to 2 times, because A dot B is equal to B dot A in vectors. Therefore it will be F2 square, same vectors. So it can be written as f1 square plus 2 f1 f2 plus yes. So since it's a dot product, so dot product always convert into cosine of the angles. So the angle between f1 f2 is alpha, therefore it will be equal to cos alpha. Okay, so it can be written as f1 square plus f2 square plus, yes, since on the left hand side it is r square, so it will convert into square root. So let this equation is the equation number 1. Okay, so now this is the resultant. Okay, magnitude of resultant. This is the magnitude of resultant of two forces. Okay, the forces are F1 and F2. Okay, now from the figure that we have drawn before, must remember that F1 force, F2 force, the angle between F1 and F2, okay, and the angle between F1 and R, which is theta, and the angle between F1 and F2 is alpha. Now what we are doing, now take the product of the equation 1 with F1. So what was the equation 1? It was R is equal to F1 plus F2. So we are taking dot product it with F1. So F1 dot R, which is equal to F1, yes, dot, it is F1 plus F2. We are taking dot product with F1. Okay, yes. So actually we want to name it 1. This is the equation 1, and yes, and we want to name the second equation, which is actually R. Yes, this one. No, 1 minute. Yes, okay. So this is F1 R cos of theta, and because angle between F1 and R is theta, therefore F1 dot F1 plus F1 dot F2. So remember that F1 dot F1 is equal to F1 square, same vectors, it will convert into square, and F1 dot F2 is equal to F1 F2 cos of the alpha. So this implies that from here we will take common F1. This is equation 3. Two, yes, this is 2, and this is equation 3, yes. So now we take F1 is common from the right hand side, and this F1 will be cancelled out. Yes, we can write it just like as, okay, or if you don't want to write it, left it just, okay, we will simplify it in the next. Now taking cross product, yes, we want to take the cross product, yes, cross product of equation 1 with, just like as first we have taken cross product dot product with F1. Now we are taking cross product, okay, with F1. Remember that you should know a little bit about physics. So it will be written as F1 cross R, which is equal to F1 cross, just like F1 plus F2. So cross product always equal to the sine of the angles, and in case of cross product, yes, this will be equal to F1 or sine of the angle, sine of theta, because the angle between F1 and R is theta. So F1 cross F2, yes, plus F1 cross F1, sorry, it is F1 cross F1, we will correct it, yes, F1 cross F1, again correct it, now it is just like as, so F1 cross F2, yes, this is actually F1, okay, yes, F1 cross F2, f1 cross f1 is 0. Same vectors, when we take the cross product of same vector, it will be equal to 0. So f1 cross f1 is always 0. So we only left f1 cross f2. Okay, and yes, it will be equal to, because we want to give the reason that f1 cross f1 is always equal to 0. So f1 f2, yes, it will be sine of the angle, and the angle between f1 and f2 is alpha. Okay, it will be sine alpha. Yes, and sine, it is theta. Yes, between the f1 and f2. Yes, angle between f1 and f2. Okay, so remember that it is sine r sine theta is equal to f1 is cancelled with f1 sine theta. Remember that this is, yes, I am actually making the voice over, so it is not, it is sine alpha. Okay, otherwise sine alpha theta will be cancelled out. Yes, it is r sine theta is equal to f2 sine alpha, not theta. I am making the voice over due to this. Okay, yes, it will be sine alpha. Now dividing equation 3 by equation 4. When we divide the equation 3 with equation 4, it will be just like, yes, r cos theta, yes, it is f2 sine theta divided by f1, yes, and f2 cos alpha. Okay, so here it will be, yes, r tan theta, and this will be equal to f1 sine theta divided by f1 plus f2 cos alpha. Yes, now theta is equal to, we can write it just like tan inverse of f2 sine theta divided by f1 plus f2 cos alpha. f1 plus f2 cos alpha. Yes, also we can take the name of theta is equal to something which is tan inverse, let it is equation 5. Okay, so we are drawing the results of these equations. So remember that I will also give you the notes that I am writing over here. You can download these notes. Okay, so now we want to discuss some special cases. Okay, so in the first case from equation 1, first of all we will write over here the equation 1. So what is equation 1? It is actually f1 square plus f, yes, this is not our equation 1, this is equation 2. f1 square plus f2 square means the magnitude of resultant that we have found before, which is r is equal to f1 square plus f2 square plus 2 f1 f2 cos of the angle between them. Okay, so now, yes, r is, this implies that r is maximum, the value of r will be maximum. Yes, when it will be maximum, when cos alpha will be equal to 1. Okay, so when cos alpha will be equal to 1, when, yes, if we want to find the maximum value of r, maximum value of the resultant, then the right hand side play a great role, and that role is that the value of cos alpha should be 1. If the value of cos alpha is 1, then it means that the resultant will be maximum over here. Okay, so cos alpha is equal to 1 means that the value of alpha, yes, cos alpha is equal to 1. This implies that alpha is equal to cos inverse 0, which is equal to 0. So thus we will put this value over there. Okay, R maximum, which is equal to F1 square and F2 square, yes, plus 2 F1 F2 cos 0. So we'll put over here it is cos 0. Since it is cos 0, therefore cos 0 is 1. It will be equal to F1 square plus F2 square plus 2 F1 F2. F1 square plus F2 square plus 2 F1 F2 and F1 square plus 2 F, yes, this will be equal to F1 plus F2 square. It is just like as, okay, and then square root. It will cancel out, square and square root will be cancelled. So this implies that R maximum is equal to F1 plus F2. So this is the maximum value of the resultant when the value of the angle alpha is which is, we take it cos alpha is equal to 1. Okay, now we want to find the minimum value of the resultant. Okay, in order to find the minimum value of the resultant, again we take the previous equation. So this will be our case 2. Okay, if it is our case 2, yes, we write the previous equations, and that equation is equation 2. From equation 2 we are writing just like as, what was the equation 2? Equation 2 was actually the resultant magnitude of the resultant of two forces. We are composing over here two forces. The first force is F1 and the second force is F2, and we have find the resultant between F1 and F2. So this is our resultant of two forces. Okay, so we want to find the minimum resultant, yes, which shows that the resultant will be minimum depend on the value of cos alpha. Okay, so if we take the value of cos alpha, then the resultant of these two forces will be minimum. So what will be the value of cos alpha over here? The value of cos alpha should be equal to, it is just like -1. So cos alpha is equal to -1, and cos alpha is -1 means that the value of alpha is of course pi. Also we can write it 180. Okay, so thus we put this value of alpha in the resultant, and this resultant will be minimum at this value alpha, which is pi. So F1 square plus F2 square plus 2 F1 F2 and cos pi, yes, it is -1. Okay, the value of cos pi is -1, so therefore we can write over here F1 square plus F2 square and -2 F1 and F2, yes, of course, just like that, and then after we will take its whole square. Okay, so this will be equal to F1 minus F2 whole square, F1 minus F2 whole square, yes, so this will be equal to F1 minus F2. This is the minimum value of the resultant of two forces. Okay, yes, now we take the next case, and this is case number 3. In this case we will discuss a little bit just like as, again we take the same equations. We are taking the equation number 2. After taking the equation number 2, it will be written just like as R is equal to F1 square plus F2 square plus 2F1. Okay, from equation 2. Yes, this is. Now we are discussing another case, and in this case we are taking the forces are perpendiculars. Means that when F1 force and F2 forces are perpendicular, when these forces are perpendicular, then it means that the angle between F1 and F2 must be 90 degree or pi by 2. So these forces are perpendicular to each other, that is the angle alpha should be equal to 90 degree. Okay, So we will put this value of alpha in the resultant. Okay, thus our resultant will be just like as r is equal to f1 square and plus f2 square plus 2 f1 f2, yes, cosine of the angle between them, which is 90 degree. Okay, so this way can be written as 90 cos 90 is of course 0, therefore we only left f1 square plus f2 square, because cos 90 is 0, so 2 f1 f2 cos 90, all values should be equal to 0. So also from equation 5 we can write theta is equal to tan inverse of just like as f2 cos of 90 degree divided by, yes, we are taking this equation 5. Okay, and this equation can be written as f2 sine 90 degree. So f1 plus f2, okay, cos 90, and this can be written as tan inverse of sine 90 is 1, so f2 divided by, but cos 90 is, so we only left f2 divided by f1. Okay, so these are the some special cases that we discuss over here. First, okay, in this question what we have to, we find the resultant of two forces first, then we find the direction, means we have find the angle theta between the two forces f1 and f2, and then we have discussed the cases. The first case for the maximum, minimum, when the forces are perpendicular to each other. Okay, so let we take another questions, and this question is related to the previous topic. Okay, here we are taking the greatest resultant of two forces. First of all, we will read the statement of this question. The statement of this question is the greatest resultant that two forces can have is of magnitude just like P. Okay, so P is the greater, remember that P over here is actually the resultant of two forces, which is the greatest resultant, and the least resultant of two forces. Okay, yes, least resultant of least, and the least of magnitude is Q. Okay, so what does it mean by? It means that show that they can, our target is that show that these two forces, okay, mean there are two forces, greatest resultant is P, least resultant is Q. We want to show that they can act an angle, show that these forces can, means force F1, if we take the force, consider the force F1 and F2, okay, show that their resultant, show that their resultant is of magnitude is R is equal, it is P square cos square alpha by 2 plus sine square Q square, yes it is sine square alpha by 2. So this is actually the required result that we want to prove. Okay, so let me start. Remember that here the greatest resultant is P and the least resultant is Q of two forces, and if we take those two forces, one force is F1 and the second force is F2, then their greatest resultant will be F1 plus F2, and their least resultant will be just like F1 minus F2. Okay, so let me write over here first. Least resultant and greatest resultant. Yes, a little bit delay over here. Okay, let me start. Let F1 and F2, we are first consider the forces, and those forces are F1 and F2. Okay, yes, least resultant is F1 plus F2. No, sorry, greatest resultant is F1 plus F2, and the least resultant is, so remember that if P is the greatest resultant, okay, yes, so theory is just like as F1 and F2 be two forces, P, okay, and P and Q be magnitude of the resultant, okay, and greatest and least respectively. Yes, the same statement that have written the question. Okay, now we write the least and greatest resultant. First we write the greatest resultant, which is P is equal to F1 plus F2, and yes, and suppose this equation is 1, and the second is Q is equal to F1 minus F2, and suppose this equation is 2. Okay, yes, equation 1 and equation 2, first we add equation 1 and equation 2. Okay, the greatest is equation 1 and the least means F1 plus F2 is equation 1, F1 minus F2 is the equation 2. After adding we get 2F1, okay, is equal to P plus Q, and here we can write just like F1 is equal to P plus Q divided by 2. And similarly, since we have add 1 and 2, now we will subtract 1 and 2. Okay, subtract 1 and 2. Okay, yes, so sorry, apologize over here that the speed is a little slow. Okay, so subtract, let me take the name, this is 1, this is 2. Okay, now subtract equation 1 and equation 2, and after subtracting, what we'll get just like as 2F2 is equal to, it is P minus Q, and from here we can write F2 is equal to P minus Q divided by 2. So we have find the value of F1 and F2. F1 is equal to P plus Q divided by 2, F2 is equal to P minus Q divided by 2, and we will put these value in the resultant of two forces that we have find in the previous topic. If all is the resultant of the two forces of F1 and F2, so what is the resultant magnitude of resultant of two forces that we have find before in the previous topic, we are doing over here example. So the last result will be used in this question or in this example. Okay, so okay, we write the magnitude of the resultant when the angle between the two forces F1 and F2 is alpha. Okay, and that magnitude of resultant is just like as R is equal to F1 square plus F2 square plus 2F1 and F2. Okay, F1 and F2, just like as, so it will be R is equal to P1 square, yes, the value of 1 is P plus Q divided by 2, and the value of F2 is P minus Q divided by 2 square plus 2 F1 means that the value of F1 is P plus Q divided by 2, and the value of, yes, it is P minus Q divided by 2, and cosine of the angle between them. Okay, this is, and then we take the square root of whole. Now p plus q square divided by 4. Yes, p plus q square divided by 4. Again it is p minus q square divided by 4, and this is 2 times of p square minus q square. Okay, divided by 4. This is square root cos of the angle between them. Yes. Okay. Now, yes, we will give. Yes, 4 is the LCM over here. Just we are doing simplification over here. So we can write 1 over 4, and inside the bracket we can write p plus q square and plus p minus q square, and it is 2 into p square minus q square, just like as plus 2 into p square minus q square and cos alpha, p square minus q square cos alpha. Okay, and we close the bracket over here. Yes, we close the cos of the angle. Yes, this is, so this can be written as 1 over 2. Yes, so we can write 1 over 4, 1 over 4 just like as, and yes, it is p plus q square plus p minus q square. By the formula p plus q square plus p minus q square, it is equal to 2 times p square plus q square. Yes, these two, plus 2 into p square minus q square, yes, cos of the angle. This is equal to 1 by 4. And yes, 1 by 4, when we write it without, yes, p square plus q square means 2 is cancelled out with 2. 2 2's are 4. Yes, that's okay. So 2 is common over here. So p square plus q square plus p square cos square alpha plus minus q square cos alpha, just like as, and the square root. Okay, it is just mathematical simplification, not so much typical steps. Okay, so you should know a little bit about mathematics. Okay, so 1 over 2, this is, you can take common over here p square, it will be 1 minus cos alpha, and when you will take q square common, it will be 1 minus cos alpha. Okay, and yes, this is equal to 1 over 2. So this will be equal to p square, 1 minus cos alpha is cos square alpha by 2. Okay, yes, this is cos square alpha by q square, and this is again cos square alpha by 2. 2 cos square, remember that it is 2 cos square. So after taking 2 common, here one thing is missing. I should write 2 cos square, q square 2 cos square, so 2 is common, so 2 will be cancelled out with the 2, and we will get the final result. Remember that it is p square cos square alpha by 2 plus q square 2 cos square alpha by 2. So 2 will be common, and then it will cancel. Since I am making voiceover, so a little bit mistake over here. Hope you have understand what I'm saying to you. Thank you very much for joining me in this lecture.